Imagine a major city rolls out this highly anticipated artificial intelligence system,
Right.
and it's designed to optimize their municipal power grid. You know, the press release is glowing, the mayor's out there cutting a ribbon.
I can picture it.
Yeah, and the dashboard looks like something straight out of a sci-fi movie. But because the city lacked a cohesive underlying integration strategy, the algorithm, which is operating exactly as it was programmed to maximize efficiency,
Oh, no.
yeah, it automatically cuts power to a critical care hospital during a severe summer heat wave.
Wow.
And that is the stark reality of government technology adoption when you don't actually know what you're doing.
Yeah, and the stakes in public administration are entirely different from the private sector.
Right.
A startup can move fast, break things, and pivot. That's their whole model. But if a public entity moves fast and breaks things, citizens lose access to essential services.
Exactly.
Or privacy is compromised, or, and this is the really scary one, systemic inequalities are accidentally hard-coded into law.
Which brings us to today. Welcome to the deep dive. Our mission today is stepping into the role of instructors, really, to guide you through a fascinating new curriculum designed to prevent exactly that kind of disaster.
Yeah, it's a vital document.
It really is. We had our hands on the 2025 UNESCO AI Maturity Framework, and this is a self-positioning guide specifically designed for public administrations to assess their actual AI readiness.
And the context of this document is crucial to understand before we dive in.
Yeah, lay it out for us.
So, it was developed within the AI-Ready Flemish Public Administration Project,
Okay.
which was funded by the European Commission and implemented by UNESCO, supporting Digital Flanders. So what we are analyzing here is a framework built specifically for real-world government application,
Right.
not just some, theoretical sandbox exercises.
Exactly. And rather than just handing you a table of contents, we are going to break down the syllabus one topic at a time, exploring the original sequence so you can actually evaluate your own organization. We are looking at a grading rubric that maps out a customized roadmap for responsible adoption.
Right, and you can see our visual backdrop has already shifted to reflect this.
Oh, yeah.
We're looking at this massive, almost blueprint-style grid representing the entire architecture of the framework. You have 6 core pillars of organizational capability running vertically.
Okay.
And then across those pillars, an organization maps itself to one of 4 progressive maturity levels running horizontally.
Okay, let's unpack this, because these 4 levels really represent the journey from, honestly, total chaos to absolute optimization.
That's a good way to put it.
So first you have basic, and this is ad hoc, undocumented. It's usually driven by that one enthusiast in the IT department who read an article and decided to buy a software license.
Yeah, the lone wolf approach.
Exactly. Then you move to ready, and this is a managed state. Processes are finally documented, and there's a repeatable, intentional approach, even if it's still, somewhat localized.
Right, it's not everywhere yet, but it's organized.
Exactly. The third level is dynamic, where processes are fully standardized across the organization. They're integrated into daily workflows and proactively measured for success.
And then finally, you reach advanced.
The promised land.
That's right, the promised land. It's an optimized state relentlessly focused on continuous improvement, automation, and closed feedback loops.
So it sounds a bit like an organizational fitness test. You don't try to run an ultramarathon if you're still struggling to locate your running shoes.
Precisely.
But if this is a rubric specifically for public administrations, why not just prescribe a target level for everyone?
Yeah.
Like, why doesn't UNESCO just mandate, hey, every government agency must reach the dynamic level by the end of the fiscal year?
The text actually explicitly warns against that kind of blanket mandate.
Really? Why?
Because a small rural municipality that's just managing local waste collection schedules, they have vastly different operational needs, vastly different budgets, and totally different risk profiles than, say, a National Ministry of Defense.
Oh, well, sure.
Or a federal tax authority. So prescribing a universal target maturity level ignores the reality of public sector resource constraints.
That makes a lot of sense.
Yeah, the framework is designed for a tailored approach based on the entity's unique goals. You use the rubric to figure out where you are today, so you can plot the next logical, responsible step without completely overextending your infrastructure.
Because you can't build a sustainable system without knowing why you're building it in the first place.
Exactly.
Which takes us to the foundational layer of our sequence. Pillar 1, strategy and value. The why.
Yeah, this pillar assesses how an organization perceives AI in the first place.
Right.
It covers the overarching AI vision and ambition, the strategic alignment, roadmap and planning,
Yeah.
value identification, and innovation.
And the leap from basic to advanced here is a total paradigm shift. Like at the basic level, the text describes AI pursuit as opportunistic and entirely technology driven. This is the classic shiny toy syndrome. A vendor comes in, does a slick demo of an AI chatbot, and a department buys it just to say they have it.
Without any thought to the user.
Zero thought given to how it actually serves the citizen.
Yeah. By contrast, at the advanced level, that AI vision is seamlessly integrated into the core organizational strategy.
It's part of the DNA.
Exactly.
Mm.
It is no longer an isolated IT experiment. It fundamentally influences high-level budgeting, resource allocation, and the long-term departmental roadmaps.
Okay, but how does this framework actually stop the shiny toy syndrome? Because we see this constantly in local government.
All the time.
A department head wants to put the phrase AI powered in their quarterly report to look innovative, maybe secure more funding. How does Pillar 1 actually expose that behavior?
What's fascinating here is how the dynamic level enforces strategic alignment. The framework distinguishes sharply between doing AI and creating value.
Doing AI versus creating value. Okay.
Right. To achieve a dynamic rating and value identification, a business case cannot just list technical capabilities.
It has to do more.
It must include quantifiable, business-aligned metrics. And crucially, the text dictates that if an AI initiative does not align with a defined strategic priority, even if the technology works perfectly, it must be actively deprioritized or killed.
Wow. So a project can be a total technical success, but an organizational failure.
Exactly.
Like the algorithm correctly sorts the emails, but if the strategic goal for the year was to reduce in-person wait times at the DMV, sorting emails didn't move the needle on the core mission.
That is a perfect example. The framework forces leadership to ask, what specific public problem are we solving?
Right.
Rather than, where can we squeeze this cool new algorithm in?
Yeah.
It demands that innovation and experimentation, which, by the way, are encouraged, eventually tie back to actual value realization.
But a brilliant value-driven strategy sitting in a binder on the mayor's desk is entirely useless if the workforce doesn't have the capacity to actually execute it.
Oh, absolutely.
We've established the plan. Now we have to look at the people carrying it out, which brings us to Pillar 2, people and culture.
Yeah, this is where the framework acknowledges that AI implementation is fundamentally a human change management process.
Not just a tech upgrade.
Right. Pillar 2 explores talent and skills, organizational structure, leadership, change management, and AI literacy.
And the basic level here sounds like an absolute nightmare scenario.
It's bleak.
AI skills are incredibly scarce. There is no defined organizational structure for AI, meaning any efforts are completely siloed. One department literally doesn't know what the other is doing.
Yep.
And because they lack internal talent, they rely entirely on external consultants to build things they don't even understand themselves.
It's so dangerous.
It's like upgrading a city's entire power grid to a nuclear reactor, but maintaining a staff trained only as coal shovelers.
Oh, that's a great way to put it.
You need the whole team to comprehend the new system, not just the outside contractor you hired for 6 months.
Exactly. And if we connect this to the bigger picture, the evolution of organizational structure in this pillar is incredibly revealing.
How so?
Moving from those isolated silos at the basic level, a dynamic or advanced organization adopts flexible hub-and-spoke models.
Okay, unpack that hub-and-spoke concept for us. How does that actually look when you walk into a government building?
Okay, so the hub is your centralized center of excellence.
Right.
That's your core team of data scientists, ethical compliance officers, AI strategists. They set the standards, they manage the heavy infrastructure, and they ensure governance.
Okay.
The spokes are the individual departments: transportation, healthcare, sanitation.
Got it.
So instead of transportation trying to build its own rogue AI in a closet somewhere,
Which happens.
it does. Or, on the flip side, the centralized IT team trying to force a tool onto transportation without understanding what transportation actually needs.
Right.
The hub provides the secure tools and governance, while the spokes provide the specific use cases and the real-world domain expertise.
So it bridges the gap between the coders and the civil servants.
Exactly.
But getting those civil servants to actually use the tools requires a very specific kind of leadership. The text points out that basic leadership views AI merely as an IT issue. Like, they sign the check and they walk away.
Whereas dynamic leaders actively model data-driven decision-making in their own daily operations. They don't just talk about it, they do it.
Right.
And advanced leaders go a step further. They proactively address cultural challenges and
That's
resistance
just huge.
because they anticipate the very real anxiety employees have about, AI making their jobs obsolete or drastically changing workflows they've used for 20 years.
Yeah, the change management category in this text is phenomenal because it actually acknowledges human psychology.
Yes.
At the basic level, AI is just forced onto the workforce with minimal consideration for the user impact. And the
Yeah.
result, users actively resist.
Or they sabotage it.
Right, they build workarounds to avoid the new AI system because they simply don't trust it. But by the time an organization reaches advanced, user feedback is actively solicited before, during, and after deployment.
It's collaborative.
The civil servants are part of the development loop.
And for those civil servants to provide any meaningful feedback, they need AI literacy.
Yes.
The framework makes it clear that AI literacy isn't just for the engineering team. Widespread workforce understanding removes the perception that AI is some mysterious, threatening force coming to take their jobs.
It demystifies it.
Exactly. When non-technical staff understand the basics of what AI can and cannot do, they actually become the primary source for identifying practical, time-saving applications in their own daily tasks.
So we have a strategic vision, and we've successfully trained a literate, culturally prepared workforce to embrace it.
Right.
But when those workers sit down at their desks on a Monday morning, what physical and virtual systems are they actually logging into?
Good question.
And this shifts our focus to Pillar 3, technology and infrastructure.
The hardware and the development environments.
Yeah.
This pillar assesses AI development platforms, cloud and compute infrastructure, AI-specific architectures, and the data science environment.
And right on cue, our visual backdrop has transitioned from that architectural blueprint to a sprawling, intensely glowing server farm.
Oh, wow. Yeah, look at
Yeah,
that.
it gives a real sense of the physical weight of what we're discussing.
It's a stark visual reminder that AI is not just software floating in the ether.
Right.
It requires immense physical compute power. At the basic maturity level, data scientists are working on isolated desktop tools. The infrastructure just fundamentally lacks the elastic computing power necessary to train or deploy meaningful models.
And the text mentions legacy monolithic IT systems as a primary bottleneck at that basic level.
Oh, yes.
Moving up the rubric to advanced means transitioning to enterprise-grade AI platforms, automated cloud infrastructure, and specialized hardware accelerators. So what does this all mean for the listener evaluating their own municipal government? Does a local city council really need an advanced, multi-cloud setup with racks of specialized accelerators just to optimize, I don't know, their public transit schedule?
The framework is actually really pragmatic here.
Okay.
It acknowledges that appropriate infrastructure scales with the workload. A local council might perfectly operate at a ready level, utilizing basic cloud storage and relying on third-party APIs for their compute needs.
So they don't need to build the matrix.
They don't need to own the server farm behind us, no.
Right.
However, where the framework is uncompromising across all sizes of government is in the AI-specific architectures category.
Okay, why is architecture the non-negotiable element here?
It comes back to those monolithic systems you mentioned.
Okay.
A legacy monolithic system is like a solid block of concrete.
Right.
The user interface, the business logic, the database, everything is tightly woven together into one massive code base.
Yeah.
If you want to integrate a modern AI model into that system, it is incredibly difficult and highly risky because altering one piece of the code can bring down the entire concrete block.
So you try to add a smart chatbot to the city website, and suddenly the municipal payroll system crashes.
Precisely. And this is why the text notes that achieving a dynamic level requires adopting architectural patterns like microservices or event-driven architectures.
So instead of a block of concrete, microservices are more like a bucket of Lego bricks.
Exactly.
The database is one brick, the user interface is another, the AI model is a third. They all operate independently, but communicate through standard interfaces like APIs.
Yes. When architecture is modular like that, deploying models into production ceases to be a monolithic nightmare.
Right.
The framework emphasizes that without this flexible architecture, moving an AI tool from a secure testing environment into real-world public service is nearly impossible, regardless of how much raw compute power you actually have.
Which perfectly sets up the next hurdle.
Right.
Having the server farm and the slick, modular data science environment is fantastic for building a model in a lab.
Yeah, in theory.
But pushing that model out into the wild, plugging it into those microservices so it can actually interact with live citizen data requires an entirely different operational discipline.
It really does.
Which leads us to Pillar 4, AI operations and ecosystem, or as we like to call it, the reality of going live.
Yeah, Pillar 4 shifts the focus from development to lifecycle management.
Okay.
It covers model deployment and management, which is often referred to as MLOps, along with performance monitoring, integration, external collaboration, and reusability.
The text outlines a brutal reality for basic organizations here. They deploy models manually, infrequently, and the transition from the developer's laptop to the production server is, quote, high friction and error prone.
Yeah, it's a mess.
It's a hand-cranked process. To reach advanced, an organization has to implement automated CI/CD pipelines, continuous integration, and continuous deployment.
And CI/CD fundamentally changes the speed and safety of deployment. Instead of a massive, super risky update every 6 months, changes are integrated, tested automatically, and deployed in small, continuous increments.
Right.
But the most critical element of this pillar, the area where public administrations face the absolute highest ongoing risk, is performance monitoring and optimization.
Because unlike traditional software, which basically stays the same until a human rewrites the code, an AI model degrades over time.
Yes, it degrades because the real-world data it encounters begins to shift away from the historical data it was originally trained on.
Okay.
And this phenomenon is known as drift.
Drift. Okay, so think about a city deploying an AI to predict rush hour traffic patterns, and it's trained entirely on data from 2018.
Right.
Then 2020 happens, remote work becomes the norm, and human behavior fundamentally changes. The AI isn't technically broken like the code is fine, but its predictions are suddenly wildly inaccurate because the underlying reality drifted.
That is exactly it. And at the basic maturity level, an organization has absolutely no mechanism to detect that drift.
Wow.
They only find out the model is failing when citizens complain about gridlock or there is an obvious catastrophic error.
Which is too late.
Way too late.
Ah.
But at the advanced level, the framework demands continuous automated monitoring.
Okay.
The system watches the incoming data streams, detects statistical anomalies in real time, and flags the drift before it impacts the public.
And the rubric explicitly states that advanced monitoring isn't just looking at accuracy and latency.
Yeah.
It's monitoring for fairness. If a model starts exhibiting biased behavior because the incoming data has drifted, the system catches it automatically and initiates a feedback loop for retraining.
Yes, and this is where reusability and the ecosystem becomes so essential.
Right.
If an organization is constantly monitoring and retraining models, they cannot afford to start from scratch every single time.
Now, here's where it gets really interesting. The text heavily emphasizes external collaboration, partnering with academia, research institutions, private startups. Right. But wait, if a public administration is supposed to be building this robust, secure internal capability, aren't they exposing themselves to massive security risks and essentially admitting defeat by relying on an external ecosystem?
Right.
Shouldn't a mature government agency handle all of this entirely in-house?
The framework takes the exact opposite view, actually.
Really?
It explicitly states that external collaboration is how organizations accelerate learning, especially in the public sector, where competing with private industry salaries for top-tier AI engineering talent is almost impossible.
Oh yeah, the government can't match Google's salaries.
Exactly. So it's about leveraging the broader ecosystem to access specialized expertise.
So you bring in the specialized startup to help build the complex model.
But it goes beyond just procurement. At the advanced level, the government organization isn't just consuming external knowledge. They are actively contributing to it. The text specifies that mature entities become active participants in national standardization body AI technical committees.
Oh, wow.
They share their best practices, they open source their non-sensitive tools, and they help shape regulatory discussions.
So it's a symbiotic relationship.
Completely.
The government leverages the academic or startup ecosystem for cutting-edge algorithms, and in return, the government injects its rigorous public sector governance expertise back into the ecosystem to help set national standards.
Yes.
But as these advanced models go live, interacting with citizens, making decisions about permits or traffic or public benefits, the risk profile absolutely explodes.
It does.
Which requires the most rigid boundaries of the entire framework. Pillar 5, AI governance, ethics, and risk.
These are the guardrails. Pillar 5 explores the formal AI governance framework, ethical principles, risk assessment, compliance and legal parameters, and transparency and explainability.
And the document is totally uncompromising here. Ethics cannot be an afterthought. They must be drawn from established international frameworks designed specifically to protect citizens against harmful algorithmic impacts.
Right.
At the basic level, development teams focus purely on technical functionality. They ask, can we build this? Completely ignoring the citizen-centric vision of should we build this and who might it harm.
Yeah, and the framework explicitly integrates compliance parameters that carry significant legal weight, heavily referencing the EU AI Act and GDPR.
Of course.
But what makes this rubric so effective is that it translates abstract ethical concepts into highly technical requirements. Take the transparency and explainability category, for example.
Yeah, because everyone agrees AI should be transparent, but actually achieving that with a complex deep learning model is notoriously difficult.
It's incredibly hard.
The text states that at a dynamic level, simply having a written policy about transparency is insufficient.
Right.
Organizations are required to utilize specific explainability techniques like ESHAP or LIME. Let's break those down because they are crucial to understanding how we audit a black box model.
So a black box model, like a really complex neural network, might evaluate a citizen's application for a public benefit and output a decision to deny it.
Okay.
But the internal mathematical weighting is so complex that even the developer who built the model cannot easily point to exactly why the decision was made.
Which is terrifying for a citizen.
Absolutely terrifying. So SHE, which stands for Shatley Additive Explanations, and LIME, Local Interpretable Model Agnostic Explanations, these are mathematical techniques designed to reverse engineer that output.
So if a citizen demands to know why they were denied, instead of the human caseworker just shrugging and saying, well, the computer said no,
Which happens.
these techniques isolate the specific variables.
Exactly.
Yeah.
A SHE per line can generate a report for the auditor stating, this application was denied primarily because of the applicant's response to question 4, which carried a 60% negative weight in the final calculation, combined with the historical data in category B.
Wow.
It makes the opaque transparent, which is a fundamental legal requirement in public administration.
But this raises a major question about how we actually grade this on a rubric.
Okay.
The text states that an advanced organization has, quote, ethical principles fully embedded in the organization's culture.
Right.
How on earth do you measure an organizational culture? It sounds completely subjective. Like, can a government actually point to a spreadsheet and say, look, we are 100% culturally ethical?
This raises an important question, right? You measure it by analyzing their standard review processes and their deployment pipelines.
Okay.
The framework provides concrete evidence markers, moving ethics from abstract conversations in the break room into the actual code repository.
How does that look in practice? Give us a concrete example.
You look at the automated CI/CD pipelines we discussed back in Pillar 4.
Right.
Are bias testing and explainability checks mandatory automated steps before a model can physically be deployed?
Oh, I see.
Is the UNESCO RAM, the readiness assessment methodology, baked into the daily required workflow for every single new project?
If it's not in the workflow, it doesn't count.
Exactly. If an organization only discusses ethics during quarterly town halls, they're operating at a ready level at best.
Wow.
If they have automated compliance checks hard-coded into their MLOS ecosystem, literally blocking any model that fails a fairness test from going live, they have achieved advanced cultural embedding.
That is a brilliant distinction. It demands proof over platitudes.
Yes.
So we have built the strategic vision. We've trained a culturally responsive workforce. We stood up the modular microservice architecture. We established automated deployment pipelines, and we locked it all down with hard-coded ethical guardrails.
We're almost there.
Now we need the raw material to feed into this entire machine.
Which brings us to the final element of the framework. Pillar 6, data, specifically with an AI focus.
And this pillar assesses AI use case data identification, data readiness, which includes the grueling work of cleaning and labeling,
Very great.
data access, synthetic data, and domain-specific understanding.
The evolution of data readiness here is profound. At the basic level, data is siloed, messy, and used opportunistically. Teams just grab whatever data is most convenient, and they only address quality issues when a model fails catastrophically in testing.
Moving up to advanced requires automated data pipelines and active learning techniques for continuous high-quality labeling.
Right.
But there is a specific capability highlighted in this text that genuinely stopped me in my tracks.
What's that?
Synthetic data generation.
Ah, yes. It is increasingly recognized as a vital capability for mature AI organizations, particularly in the public sector.
Wait, hold on. If we are evaluating public administrations agencies responsible for actual citizens, actual taxes, actual infrastructure,
Yeah.
why would they intentionally generate fake data? Doesn't training an AI on synthetic data completely defeat the purpose of preparing it for the real world? Shouldn't an AI meant to serve citizens be trained on the actual data of those citizens?
It's a highly logical pushback. I totally get it. But the framework explicitly outlines why synthetic data, which is frequently generated using advanced architectures like GANs, generative adversarial networks,
Ooh.
why it solves several massive public sector bottlenecks.
Walk us through those bottlenecks, because it sounds crazy at first.
The primary one is strict privacy constraints. Government agencies hold the most sensitive data imaginable, right? Health records, financial histories, criminal records.
Yeah.
Developers need massive amounts of data to train a deep learning model, but exposing that real data to a development environment is a massive security risk and often flat out illegal under GDPR.
So they use GANs to synthesize a data set instead.
Yes, the synthetic data maintains the exact statistical properties, correlations, and complexities of the real citizen data, but it contains absolutely zero sensitive, personally identifiable information.
Ah.
Developers can rigorously train and stress test the model safely without ever touching a real citizen's actual file.
Okay, that makes sense from a privacy standpoint. What else?
It actively combats historical bias.
Oh, really?
Yeah, think about it. If a city wants to train an AI to optimize loan approvals for small businesses,
Okay.
but their historical real-world data underrepresents a specific demographic due to decades of systemic redlining, training an AI on that real data will simply hard-code that historical bias into the future.
The AI will just learn that the marginalized demographic shouldn't get loans because historically they didn't.
Exactly. It just learns from the past.
Yeah.
But a mature data team can use synthetic data to artificially balance the training set.
Wow.
They generate statistically accurate profiles for the underrepresented demographic, ensuring the resulting AI model evaluates everyone fairly based on merit, not on historical prejudice.
It's essentially using fake data to force the AI to be more objective than human history has been. That is a superpower.
It really is. Furthermore, synthetic data allows organizations to simulate edge cases.
Edge cases.
Yeah, these are rare, catastrophic events that haven't happened often in the real world, like a 100-year flood or a localized grid collapse.
Right.
You don't have enough real data to train an AI on how to respond to those events because they don't happen often. So you synthesize the data to ensure the model knows how to handle the anomaly when it finally does occur.
That's fascinating. But the framework doesn't just rely on clever algorithms to understand data. The final category in Pillar 6 is domain-specific data understanding.
Yeah.
And it brings the entire framework back to the human element.
Yeah, the text is absolutely adamant that data scientists cannot operate in a vacuum. If technical AI teams do not collaborate intimately with subject matter experts, the SMEs, they will fundamentally misinterpret the business context of the data.
Meaning you could have the most expensive multi-cloud infrastructure, perfectly automated CI/CD pipelines, and beautifully balanced synthetic data.
Yeah.
But if your brilliant data scientists don't sit down with the actual civil engineers, the frontline social workers, or the veteran tax auditors who understand the nuance of what those numbers actually represent in the physical world,
Right.
the model will draw the wrong conclusions.
Precisely. At the basic level, technical staff make assumptions about what the data means, resulting in models that are technically functional but practically useless.
Yeah.
And the advanced level, the framework dictates that AI teams must either possess deep domain knowledge themselves, or they must have SMEs embedded directly into the development team, formalizing that human domain understanding into the very architecture of the data pipeline.
Well, we have successfully mapped the entire 2025 UNESCO AI Maturity Framework.
That's quite a journey.
It really is. We started with the vision, we built the organizational culture, stood up the compute architecture, automated the deployment, locked it down with explainable ethics, and fueled the entire system with pristine, bias-corrected data.
It is a rigorous, holistic journey, no doubt.
Synthesizing this deep dive, the real utility of this document is the 5-step workbook process it provides for organizations to actually use the rubric.
Right.
Step 1, understand the framework. Step 2, assess your current capabilities across these specific categories. Step 3, identify your capability gaps.
The hard part.
Yeah, definitely. Step 4, synthesize those results to determine your overall maturity per pillar. And step 5, finalize action points to build your roadmap. The value here is providing an escape route from the basic trap of just chasing shiny buzzwords and moving toward a state where trust, transparency, and efficiency become strategic differentiators for a public administration.
Absolutely. But as we conclude our analysis of this curriculum, I want to leave our listeners with a broader implication to consider.
Okay, let's hear it.
We've detailed an incredibly demanding path to advanced maturity. It requires flawless MLOps integration, deep ethical embedding measured by automated pipelines, a transition to microservice architectures, and the capability to generate cutting-edge synthetic data to protect privacy.
It is an astronomically high bar for a government agency.
It really is.
Yeah.
So if this comprehensive framework represents the new standard for responsible public administration, are we establishing an evolutionary benchmark that only a few highly funded, massive federal or state agencies will ever actually possess the resources to reach?
Wow,
And if that is the reality, how do we prevent the emergence of a two-tier digital society? A future where citizens in well-funded jurisdictions interact with advanced digital governments that are fair, transparent, and highly efficient.
while others fall behind.
Right. While citizens in smaller municipalities or underfunded regions are left navigating basic, error-prone, black box algorithms that nobody has the expertise to monitor or even explain.
That is the essential challenge of this technological era, because if a standard IT system crashes in one city, it's a localized inconvenience.
Yeah.
But if the foundational AI governing our public services, determining our permits, our infrastructure, and our benefits is fundamentally mature and ethical in one zip card
Yeah.
and totally ad hoc and biased in the next, we are just automating systemic inequality. The muddy waters of government technology are deep and complex, but thanks to this framework, we finally have the rubric to measure exactly where the dangers lie. We highly encourage you to dig into the AI Maturity Framework Workbook, grade your own organization with brutal honesty, and take those insights to your next strategic planning session. We'll see you on the next deep dive.